So if you haven't opened your books up, it's 510, page 510, I believe. Pretty sure.
Good job.
So the top of 510, there's a diagram there. This is the AWS's, basically their diagram for what print reading for welders, or welding joints, things like that. It's kind of what they use. Now, this is kind of a confusing thing to try to figure out yourself, so that's where I come in. We're going to kind of decode this thing. There's some stuff on here that we really don't necessarily need to know at this point, but we're going to cover the majority of this. Plus, we're kind of carrying over from last week's quiz on some of those groove joints too. So we're going to show you how they all kind of apply. So the very first thing we got to do is we got to look at this diagram right. Now there's actually three components to this diagram. This is, I think, obviously the arrow. This is the reference line. And this is called the tail. Now the arrow is pointing to an area that is to be welded, kind of. I will say it as that because depending on where information is on the reference line actually really determines where the weld is going to go. So the arrow is pointing to something. We're going to come back to the reference line, and then we go to the tail. Now the tail is actually really, really easy. That's why I want to kind of start there, is that it is for general information. Normally, probably for the most part, you're not even going to see a tail. If there's something specific that they want you to know on that tail, whether it is C note 1 or C reference 1 or something like that, they may put that in the tail section. Or in this particular case, everything else is stick welded, but in this one they put GTAW for that particular weld because it needs to be TIG welded. Something like that can be why we use a tail section. But other than that, really it's just for information. There's really nothing more than that. And it's not really something that needs to be decoded too much because you should have normal type of notes right in there. You're not going to have a symbol, you're not going to have anything like that. So the reference line, this is where basically most of our information is stacked on or written into. I say stacked because it depends on which weld we're actually doing. Because we have, and we talked about this last week, although there's 5 of them, which 2 welds are we really focusing on? Grooves and fillets. So grooves tend to be stacked information, fillets tend to be from left to right like our normal reading pattern. And it's really depending on the way you weld it. So the first thing we want to talk about is where is the information going to go? Does it go here or does it go here? Well, that is depending on where the weld is actually going to be. So we're going to say that any information here is going to be on the arrow side, and any information that ends up on top of the reference line is going to be referred to as the other side. So if the information is below, it's going to be really where that arrow is pointing, but if it's going to be on the other side, it's basically the other side of the weld. So, for example, we'll do a standard T. And if we have information here, we're talking about welding on that side. If we've got the information here instead, we're going to be on this arrow side here. So that's determining where your weld is going to go. That could be doubled up. Maybe there's a weld on both sides. So you may have a mirror of the information. So either way, still referring to arrow side and other side whenever we're doing this. Now let's talk about the basic weld symbols, because we've actually kind of gone through this already. You got this information, but you just didn't realize you got the information because I didn't really refer to it exactly as a weld symbol. So if we've got our normal T-joint, and it's going to be what kind of weld? Fillet weld. So if we just kind of look to the side, this is basically where the weld is going. Now obviously there's going to be some penetration into it, but this area right here would be the weld area, right? So guess what? The fillet weld symbol is that. It's exactly how it looks basically on the drawing like this. Now we went through the groove welds. There are multiple groove welds, and the groove weld is a weld and it is a preparation on that joint. What did we say? What kind of groove weld did we call this one? Square groove. Square groove. Well, square, I'm just going to put square here. Those two lines where you butt those two pieces up, that is your weld symbol right there. What was this one? That was a bevel groove. So kind of an upside down here. V groove. This is the only time it actually kind of changes up a little bit. Well, U and J. Because it has this little stemmy there. Now, that's really, it's for drawing purposes. Because if you looked at it, when we made our reference line, and we just did this, but so we got a little sloppy, and they did it this way, and those lines kind of blurred together. Guess what? It's kind of hard to tell the difference between U and a square. So they make this little stem on there. To make it a U groove. Or a J. It can be the same. Same thing, stem, just half for the J. So that makes sense so far, right? We did kind of cover those. It's not that difficult. So these are our basic weld joint, or welds that we're going to do anytime we're back in that lab. How they are put onto the reference line, that changes things up. And we do have to work on some things like dimensioning and stuff like that. But so let's draw a couple things out real quick. I'm not going to put dimensions on this. We're not there yet. Okay, so if we see something like that, what's it telling us? The square groove where? Where do we weld it? So the bottom section right here. That's where our weld would go. This is the other side. Now what do we got? Fillet, same side. So, not same side, but
V on the arrow side.
arrow side. Just making sure that when you're talking terminology for welding, we need to be kind of exacting because it could be taken different ways. So specifically, that would be arrow side. So it's a fillet weld on the arrow side. Pretty simple so far. And you know what? The majority of what you're going to run into is probably literally that easy. Okay? So let's take a little bit more. So what we have here is we got two little guys that I want to talk about real quick. So let's go back to the reference line. So we know information is going to go on here, other side, arrow side. What does the book say about that one?
Field weld.
What does field weld mean? Any idea?
Well, I gotta put it together and weld it on the side.
Okay, yeah. That could be, that definitely could be one of the definitions, that it's going to be welded on site. Now, what could also happen is maybe there's some dimensional stuff that's we're not sure about. Maybe an elevation something needs to be cut first and then welded into place. Maybe they don't know what's going to be on one side of it. Maybe there's some unknown. So they're going to flag it as a field weld, and they're going to say, you know, when you get to the site, this area does need to be welded, but you weld it how it needs to be to make it fit where it's supposed to go. So that could be it. Now, there's another side to it, and this is, you know, maybe slightly controversial, like slightly making fun of engineers a little bit, but here's what happens kind of out there. So let me give it to you like this. How many schools in Michigan offer mechanical engineering? A lot. Like 100? Just about every college offers some kind of mechanical engineering. So, how many in the Midwest?
Probably the most.
Probably a ton.
Yeah.
We can say buttload, whatever you want to say. That's a lot. How many in the country? You know, just keep adding them up. Tons and tons of mechanical engineering programs. How many welding engineering programs in Michigan? One.
I mean, what kind of engineering?
Welding engineering. One. How many in the Midwest? How many in the country?
3. 5.
Somewhere around there. About 9. Maybe a few more here and there that I don't know about, but not many. So my point is this. A mechanical engineer is not going to know, they've gone over this and the computer program, you know, helps them out on this, but sometimes they just don't know. If they're a new person to the job that deals with this kind of stuff, they may not know. That's where that comes in. They kind of rely on that to flag something, saying basically, hey, you're the journeyman welder, or you're the welder on the site. You should know how to do it. So how about you just do your job? I mean, it really is, it kind of comes down to that to a certain degree. So just understand that not every flag means that, oh, you know, this is going to be absolutely out in the field. It may just be because they're not sure exactly what it's going to take to hold it together. They may know some of the numbers, but if they're kind of new to the job, they might not know everything about the weld or the welding sections. Okay, it's just the reality. There's just not that many welding engineers out there. I mean, really, you know, there's Ferris State. There's actually only 3 ABET certified programs in the country. It's Ferris State, it's Ohio State. The difference between those two, though, is that Ohio State is more theoretical. Ferris State's a little more hands-on. There's Litorno University down in Texas. I'm sure everybody's heard of that powerhouse university. They've got an ABET certified program too. That's it. That's all there is. Then Penn State kind of has an offshoot campus that has welding engineering. Montana, a place called Webster State. You know, I mean, it's just here and there kind of like this. And even then, you know, there's not that many people going into it, although there is a need. Ohio State actually shut down their master's program for welding engineering. They weren't getting enough people. They ended up shutting it down. They got a bachelor's, but they don't have a master's anymore. So, you know, it's kind of a weird little area, but there is actually a pretty big need. So a lot of times, if you run into a welding engineer, they might not actually have a welding engineering you know, degree that says it. They may know a lot about welding, or they are a certified inspector or whatever, and they basically said, you know what, you're the welding engineer. That's kind of what ends up happening with those guys. Okay, here's another one. Weld all around. So here's kind of what happens. Now we are in a little bit different age where a lot of our prints are going to be computer generated, and those programs now happily will put three-dimensional views, because a lot of them you have to actually design in 3 dimensions and then break them out into 2 dimensions versus designing with 2 dimensions and having to run projection lines and everything else and try to create an orthographic view or a 3-dimensional view. But when we're looking at a print, you're not always going to have that 3-dimensional view sitting there. So, you know, sometimes things can be a little bit deceiving, and we kind of get into a little bit of a blinder situation where where's most of our information? Because normally your print is going to have a front view, a side view, and a top view. And when you're looking at those views, that's fine. If you can mentally put those into a 3-dimensional view and kind of see it, you know, more power to you. That, you know, not everybody can do that. But because maybe all of the dimensions, or most of the dimensions, and most of the weld symbols are on one view, we kind of start looking at that, just that one view. Kind of forget a little bit about the other views to really see what's going on. Now, I'll just illustrate the point. This is a really, really simple one. And you'll probably pick up on it pretty fast, but not everybody does. Okay, so what do we got?
Yeah, fill building, all of them.
Okay. Where is the fill weld? Okay.
All around on the side.
All right. Do we know what this looks like yet? No, we don't have the other 2 views. So let me draw the side view. Does that side view make sense? Shouldn't, unless you already know what this is going to look like, which some people may. That's fine. Let me draw the top view.
circle.
Does it make sense now? Let's look at it in 3 dimensions. Remember, in a print, you're not going to see curves unless it shows up in that direct view. So if we're looking at this directly on, you're going to see square lines. The only time we actually see any curves is in that top view. Now, the important thing here is this. We said we have an all-around symbol, a weld all around. We also have a fillet weld, and we have a fillet weld on a certain side of the reference line. This is where it could get a little confusing, except for this. Which way do we read? Left or right? Yeah. So think about that as the order of operation also. Different from math. We're not doing math here, don't worry. The order of operation is defined by left to right. So if we say weld all around, fillet weld, but it's on the top, does that matter? Well, guess what? Does this change this print? No, because the weld all around symbol trumps what side that goes on. It's natural to just put it on the top. If you're doing it on the computer, if you're drawing it out physically, it's just easier to just draw that fillet weld symbol on top of the line. But this trumps where it is, this side or this side. This is already telling us we got to weld all the way around it. It doesn't really matter. It really didn't change anything. It's, except for maybe the idea of where to start, but really where to start and where to end isn't that big a deal unless there's something critical on where the starts have to be, where the stops have to be. Other than that, it's not really critical. We can start anywhere around this thing. As long as that weld is good all the way around, it doesn't matter where we start or where we finish. It's still welded all the way around. Okay? So think about it in that sense that fillet welds, we're going from left to right. Now, again, what I said was groove welds are actually going to have stacked. So we're going to start looking at some dimensional stuff now.
So which one is that actually?
That's a fillet weld?
No. The whole thing is the.
What about it?
It's below above the line, or it doesn't
It
matter.
doesn't matter because we still got to weld it all the way around anyway.
Okay. Got it.
So it trumps that arrow side, other side idea. Now, size of welds come before the actual weld symbol. And we're strictly talking about fillets again, because on a groove weld, we really don't have size of weld. If it's prepped like this, we got to fill that thing in anyway. So it's really not an issue about size of weld. You can have an issue of how much underneath or how much over the top, but as far as the size of the weld, no. Same thing here. We got to put weld all the way in this thing. We got to put weld all the way in. Don't care what the size it is. You got to fill the shit up. You know, it's really how it works. But here, we do have possibly some dimensional issues about where it goes. You know, how big it is. So let's look at it like this. Okay, so 3/8, and that's, what is that? 3/8 is what? 3/8 of an inch, 3/8 of a foot. Generally, it's 3/8 of an inch. If you've seen it in a fraction form, it's inches. You could come up where it's in metric. Maybe they say 4. Well, a weld shouldn't be 4 foot long, so we can kind of assume right away that it's metric, but somewhere on that print, it'll say whether it's in standard or metric. So just make sure you understand that you could get either one. Remember, you know,
So is that
us and two-third,
millimeters, then, right? Just the four is the measure?
yeah, but it'll say, you know, maybe inches to millimeters or something like that on there. Yeah. So, yeah, I mean, just understand, you know, us and the two third-world countries, are the only two countries in the world that still use traditional measuring methods, even though the military and most engineering and just about all of the auto industries and everything else, aeronautics, everything is already metric. Why we're still using this? Does anybody understand that we can like totally eliminate fractions? Just go over to the metric system? No more fractions. Fractions screw people up all the time. The numbers get bigger, but that's smaller. And people are like, what? Why? What? But yeah, unless you're actually, you know, really showing them, if you're just talking about it, it can kind of get kind of confusing. So when we look at this 3/8, what is the measurement? What do you think is the measurement for a 3/8 weld? How do we measure that? So we got this weld here. Where's the measurement?
The width of the weld,
The width. Which way?
horizontal,
Horizontally?
How big the bead is?
Okay. How though? Because we can look at it three different ways, to be honest with you.
How big the weld is?
Okay. Is it
Sticky?
Is it this? Is it this? Or is it this? Remember, there's three there.
First.
That's the face of the weld. That is not, actually, because that's what a lot of people assume. So don't, you know, not that that's a bad answer, because when you're looking at the weld, really, that's physically what you're looking at. But that's not the size of the weld. How many legs do we have? We have 2 legs. And welds have 2 legs. Okay? This is a leg of the weld, and this is a leg of the weld. Right there. Those have to be 3/8. Both those have to be 3/8 to make it a 3/8 weld. If for some reason you screwed it up and say this is going to be a quarter when we measure, but this one comes out 3/8, guess what? That is now a 1/4 inch weld. You have to go with the smallest number. And yes, 1/4 is smaller than 3/8. Because a 1/4 is 2/8. You always have to go with that smaller number. Now, how do we measure that? You know, that's kind of hard to measure necessarily, you know, when you weld this piece. Now, it's pretty easy if we were to cut a section out of it. We take that section, well, it's not really easy, but we polish it to where it's a mirror finish. And we take it, we dip it into a nitric acid bath, and which then etches where the weld is in there. Now we can measure that weld. Yeah. So realistically, that's not very practical. We actually do have tools for that. This is a fillet weld, so a series of fillet weld gauges. So basically, you would take this guy. You go this way with it. You go this way with it, and that would give you your measurements. You'd have to, if one doesn't quite fit in there, then you got to find the one that fits to make sure about the measurements. Now, how critical is that? Probably for most welding, it's not that critical. But on those rare occasions, it might be really, really critical. It might be critical in trying to get a job. They may throw something like that at you in a weld test because they can. But when you get to the job, if you actually pass everything and you get the job, then you start seeing the prints. Probably none of them have, you know, measurements on it. But that's just kind of the reality. So that is where we measure those welds at. So 3/8 would be that dimension of the weld. Now we can add something to this now, and that's going to be after Hey, Brett. And that's going to be after the print symbol. And let's just do this. Now we're reading from left to right. So 3/8 fillet weld. What do you think the 4 stands for? Since we already got the size of the weld, what do you think the 4 would stand for? Length of the weld. Yeah. So we got the size of the weld, now we got length of the weld. And this would be 4 inches generally, unless we go into metric, and then it's going to be different. But yeah, so it's going to be a length. So before the fillet weld symbol, size. After the fillet weld symbol, length. All right, so let's go to the groove. Let's start kind of dealing with grooves for a second here. Because we'll get back to this one because there's something I want to add to that. Now the preparation for your weld is not going to be on the print, it's going to be on the symbol. So your butt joints will always look this way, and that would generally be a square, but you got to look at your print symbol to actually tell you what is the preparation. So we have what? We have a V groove on what side? On the other side, so that's the bottom. So we have to prep this in a V. Well, we don't have that dimension yet. This is where we start stacking information on these ones. They don't go from left to right here, we start stacking. So it's a V groove. Now we need a dimension. And the dimension usually goes about right here. And this is going to be in degrees. So that V groove has to be 75 degrees. So our bevel needs to be what? What's that? No. Because the bevel is only one side.
15. We wouldn't make a 90-degree angle?
No. We're not looking at 90-degree angles.
Well, it's 180.
No. 75. If this is going to be the V. 37.5. So now, what is the bevel? So what is it? 37.5 degree bevel. That sounds like a really random number, right? It's not. That's why I use that number. That is the standard bevel for any pipe weld. Any pipe weld, if you go to buy a piece of pipe that has it pre-beveled, it's going to be at a 37.5 degree bevel. That's the standard beveling dimension. So yeah, so if you've got to do the prep on it, remember they're giving you total dimension on the V, but you can't necessarily put total on there when you're working it. You got to go from one bevel to the other bevel because it's 2 pieces. Does that make sense? Okay. So what else can we do with this? So we've got. Let's look at this. Let's look at this symbol for a second. So what we've got here is what we've done is we've done the arrow, we've done the well all around, we've done the field well, we've done length, but we haven't done that thing called pitch yet. But we'll get to that. We have a tail section. We have the actual welding symbol. We have a groove angle included, or countersink, but we're not dealing with plug weld, so it doesn't really matter. So And you can see there's still some stacking things there. And we have what's called a contour symbol and a finish symbol. Generally there's 3 of each, okay? Contours are easy. You have a flat contour. They may call it a flush contour. I call it flat, they call it flush. I've heard it used both ways. Then we have a concave and we have a convex. Now, that comes into play a couple different ways. Sometimes, and this isn't too common, honestly. Sometimes you might see a contour symbol say on a fillet weld, where because of some kind of tolerance or clearance that they need, they may tell you that that weld has to be concave. Just for reference for you guys, just in case trying to remember which one, I always think of it in terms of concave caves in, and then flat is flat, and then convex is rounded. So I always kind of think of it as concave caves in. So for groove welds, you don't see a whole lot of a contour symbol except for that flat or flush symbol. In the fillet welds, all you're really seeing is either flat or flush or a concave. Convex, not that often. You're not going to see that asked for too often at all. This is going to be dependent on the second part of that, which is the finish symbol. And the finish symbol can be one of 3 letters. There's actually more, but for our book and everything else, these are the only ones we're using. And these aren't as complicated as they even seem to be. So, who's done some stick welding in here? Okay? After you're done with the weld, you get done, you break your arc, what do you do with that weld? Pop. And? What do you do?
Don't you chip it?
Chip it. Chip it with a chipping hammer. So guess what C stands for? Chip. Yeah. Now, if we want to start cleaning it up even more, we just take it another step. So what do you think G would be? Grind it. And then if you want to take another step a little bit more, we could also do what to it? Machine it. Yeah. So chip, grind, machine. Those are the 3 for doing your finish work, essentially. So, if we did this, if we stack a couple of these on here, we can then go here and here. We're basically just saying that it's a V groove, and when we weld it, so it's a V with a 75-degree total angle. Our bevel's of 37.5 degrees. You're going to grab your rod. You're going to run, say, a bead here, a bead here, and a bead here to finish that thing out. Now, if you look at that, this is the surface. This is a little bit higher than the surface. Now, there is a tolerance. We're not going to get into it here. Don't worry about it. We'll get into it in 101. That surface cannot be above 1/8 of an inch. So up to 1/8 of an inch, but above 1/8 of an inch, it's out of tolerance for weld inspection. But in this case, we're going to have this finish symbol of flush or flat. So this actually needs to go away, and we're going to use a grinder to grind it down. Now, if everything goes good, that should look nice and flush. This is a ground down surface. So this was a weld right there. Once you ground it down, there was no divots or anything in there. So that would be a finished weld at that point. Yeah.
So the line above 75, that's for flush.
That's for a flush contour.
Okay.
Yep. All right. on, let's add one more thing to a fillet now. I'm actually getting close to being done already. Even though it seems like there's a lot of stuff here, it'll make sense though. So let's go to another T. I'm not going to mention on there, but let's go with. So when you see another number past the length, that is referring to what's called a pitch. Now understand that again, we do have a lot of different terms that are used in welding that may not translate over into other industries or vice versa. For example, a pitch in terms of roofing means what? The angle of it. Yeah. We're not dealing with any angle here at all. So it doesn't even apply at all. Obviously we're not pitching in baseball. So now we have basically a different definition of what pitch is. So when we see this, we're actually talking about a stitch or intermittent weld. I use those terms. Intermittent just is a longer term. I call it a stitch weld. That's the easier term. So let's look at that. Okay, we have our T-joint. So we've stitched it together. Now, the reason why you would do that, maybe it's not really structural, and in order to save some time, you can stitch it together and go on to the next one. It may just be a reason to do it like that. It's not really something that's structural this way. So this dimension of 4 inches for the length is right here. Now, where does the 10 come in?
10 is the overall length.
Okay, it is the pitch. 10 is the pitch. But what it actually determines is not anything to do with the length of that or the gap, but it is a center-to-center dimension. So when we talk about a pitch of a weld, we're actually dealing with from the center of one weld to the center of the next weld. So what is the dimension of the gap between the two welds?
Six.
6. Yeah. Now, I can show you that it doesn't have to be even that complicated. If you've got pitch and length, work smarter, not harder. So why would that be? Why would we want that? Anybody know? Here's the thing. If we got a really long piece, let's say this thing is 8 inches long and we're doing 4-inch stitch welds. Or I'm sorry, 8 feet long, but 4-inch stitch welds. If that dimension of 10 was really just the gap, or they gave you 6 as the gap, if you're slightly off on your start of your next one, and then the start of your next one, you're slightly off again, the start of the next one, it will be an extreme amount at the end of that 8. But if we're doing center-to-center dimensions, you'll be in more tight tolerance. So that's why they do it that way. It's just a closer tolerance to be able to measure that out. okay? But that's pretty simple stuff right there. I mean, really, this is kind of the gist of what we're dealing with here. Reading a print really is not that hard. You've got a lot of dimensional stuff. In terms of what we're going to be doing, the dimensions are pretty simple. You know, you may be cutting a 2-inch by 6-inch piece of steel. And then you're going to cut another 2-inch by 6-inch piece of steel. Then you're going to take those two and you're going to butt them up to be a square groove weld. That's pretty simple. Pretty simple stuff right there. So it's not going to be hard to figure out any of my prints, but the more you get used to reading a print, the better you are. I mean, you'd be surprised now. I mean, I get calls all the time for jobs. And the main thing now is not to be able to weld off of what's called a fixture. Because a fixture is basically designed to put the parts already in it, boom, 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 weld it up, get it out. Now this is production stuff. Trust me, if you've got to go there to get that initial job, to get something on your resume, do it. But don't look at it as a long-term thing, because I don't think any of the companies that do it think of it as a long-term thing. Maybe they hope to, but production welding is kind of a bear. It's not really going to be a long-term job. I don't care who you are. It really is. But more and more of them are looking for, and they actually used to call them sometimes like builders or machine builders or fabricators. Well, now they're just looking for welders that can read a print and build something off a print. They're not using the other terms as much. You still see fabricator once in a while, but you're really now seeing just welder, and in the description, read prints. You know, that's kind of the change that I've seen more often than not lately, is that they're just looking for someone who can weld and read a print so they can build something off of a print. Because maybe they're doing more one-off pieces. It's kind of what happens a lot of times at, you know, I'm not a big fan, I'm not pushing for this place, but that's what a lot of times happens at Roush, because they do a lot of one-off pieces at Roush, so they may be working off of a print a lot of times. Roush kind of sucks to work for if you don't get the right supervisor. I got some really shitty supervisors, but other than that, yeah, that's just how more people aren't going to work. Okay, so let's look at this thing again. Now, a couple things we didn't really go into. There's a part on here that says effective throat. You see an E with parentheses. Here's the problem with that. What is effective throat? We actually have 3 things that can be what's called a throat of a weld. And that is theoretical throat, effective throat, or actual throat. Now, how do you measure that? Remember how I described it with polishing it up and putting it in the etching solution and stuff? That's the only way you can measure that. It's not something you can measure with tooling that I'm using. Here's what the throat is. So I'm going to give you a weld that is concave. So, and then I'm going to show you the penetration into the weld. So this dimension and this dimension is one of the throats. Then this dimension, and then this dimension is one of the throats. And then this dimension, and then this dimension is one of the throats. How do you measure that in a print to a solid piece? You can't. So I hate the fact that they have a throat on here, effective throats. You can't measure it. It's not something that's realistic. Okay, I've never seen one that has effective throat. The other one is depth of penetration, size, or strength for certain welds. Sure, but again, that is not something that when you weld a piece up, that most people are going and then cutting and then etching and then looking at the penetration and then testing for strength. in a normal situation, that doesn't happen except for either by a welding inspector or by an engineer or something like that. The other one is the root opening. Now, we could give you a root opening, and maybe some prints will give you a root opening. And that root opening would be, we have two different terms. We have that was on your list of terms. Anybody know what those meant? And we kind of talked about this last week. This is root opening, right here. That spot right there.
The side of the,
Yeah. So they could give you the size of the root opening, but guess what? What if they're wrong? What if they tell you that they want you to use this rod, but they put the wrong number on there? It's just going to screw up that well. So really, again, I would prefer you to go back to the rule of thumb of using the end of your rod to verify what the root opening actually is. Because if they didn't know, if they don't have any kind of practical welding experience, and they say that they want an 1/8" gap right there, but we want you to use 3/32 rod, it's not going to work. It's going to be too big of a gap. You're going to be sitting there going, filling this huge area up. It's just not going to work. So I would prefer that you are actually setting your root opening. So that's why I'm not really going over that. So what did those mean? Anybody? Okay. Guess what question is going to be on the quiz next week? We don't have enough time in the day for open book quizzes. Oh, I tell you. Now, it is partial joint penetration and complete joint penetration. If a weld is butted up tight, you're probably looking at a partial joint penetration, meaning that it's not going all the way through. But if you've got root openings and things like that, you're looking at complete joint penetration. Meaning that if we're going to weld this up, your first pass may be right here, and what it's going to do is going to come out here, and then boom, 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 and you got the weld, and it's complete, 100% from here to here. If we butt those up, you might not get that all the way through, but it may be calling for a partial joint penetration anyway. Maybe they don't want it to have complete joint penetration. There's differences, and it can be called for it like that. My code book has tons and tons of these little drawings that are partial joint and complete joint penetrations. Not that necessarily you got to do one or the other. It really depends on what the job is for that part. Okay. So again, like I said, we're not really going through that one there. So if you look underneath, or for that book, the next page, just look to the next. Yeah. So that's basically what we just went through. So we did the type of welds. We did fillet, square groove, V groove, bevel groove, U and J groove. We did talk about plugs and slots, nothing big there. We got field weld, we got weld all around, we got concave, convex, and flush. And then we did go into the finish symbols on that too. The rest of what this is not, like I said, seam welds and stuff, no big deal there. But most of what we just did is what you'll see on a general print.
Quick question.
Yeah.
The diagram up there, the orientation of the welding symbol doesn't matter?
It doesn't matter. Okay. Yeah, just I'm writing, so I wrote it off to the right. You'll see some that are off to the left also. It doesn't really matter. It still is arrow side, other side. That stays the same. No matter which way it's oriented. Okay, so let's do this. We've got a little handout here. For those on video watching this, you'll need to get this handout from me at some point.
Answers in the book?
Answers to what? This? No. No, we're going over this right now. And then we're going to do a quick little review of what the quiz will look like. because I don't have my quiz totally done, but I'll give you a good flavor of what it is. And these are new ones. I haven't even looked at these ones yet. I had some other ones I was using, decided to change it up a little bit. So let's look at this print. First one. We got one more. Oh, sorry. First one, U.S. Composites Corp. This is your title block at the top bottom corner. Always make sure that you're kind of checking that, make sure there's really no big notes on there for anything. Also look around the prints themselves to make sure about notes on there, because you may have something. This one not necessarily. Let's see here. We have 3 different views. They are labeling them view X, view Y, and view Z. Let's start with this. Just count how many weld symbols do you see in this print? All the print symbols. 4. What do you got? You got 5? We got 4, we got 5, we got 3, 6, we got 6. Okay. Are we sure?
No.
Okay, let's start with view X. First one from the left, 1/4 inch fillet weld, flat contour with a P. Now, in this case, we're not using a P finish symbol, so I don't know what this is. It's probably something specific to this print. It's probably on a note somewhere what P finish symbol is, so I'm not going to worry about that at this point for what we're doing. And then we have a 1/8 fillet weld contour symbol of flush, flat, but in 2 different spots. Both sides. So now let's look at one of the other sides. Yeah. It's probably something specific for the brand. So let's look at view Y. Why does it show it twice? See where there's an arrow that shows 1/4 inch thick by 2 1/4 steel bar type? There's 2 of those. So technically that's 4 right there. Because we're welding on the front side or the arrow side and the other side twice. Because there's actually 2 of those. But because of the view, they're only showing 1. Because they're basically lined up together. So we're actually welding 2 of those. So on view X, how many print symbols are there on, or how many weld symbols are on there? 5 on view X. 2 arrows. They're using 1 reference line, but there's 2 arrows. So what about view Z? How many weld symbols? You not see it?
No.
This bracket here, there's 2 of those. You gotta load both of those. Both sides. So 1, 2, 1, 2. Yep. 5 on X, how many on Z?
The other one on X, some 3 symbols, but what are the?
No, you see 3 arrows,
On X.
right?
Aren't you welding in the same spot where the arrow?
No, there's 2 of them. This here is right here. There's 1, there's 2. Okay. You see it? See this thing here? That's 1, that's 2. So we're welding 2 of those plus this. So there's actually 5 symbols. There's 2 on this arrow, 2 on this arrow, 1 on this arrow.
Okay, so you're saying the combination of U, X, and Y side.
Well, yeah, basically. I mean, I wouldn't look at it necessarily exactly like that. But there's 5 here. It refers to this. So how many on Z? 2. How do you see 2?
Where says B, the circle? What's that?
Where it says B?
Yeah.
What about it?
Towards the right.
What does B tell you? It's just a measurement.
Oh, okay.
That's not a weld symbol anywhere on that.
Oh,
But we've got a 1/4 inch fillet, 3.5 inches long. And that's the only one, and it's on the Euro side. So there's 6 total on this one. And remember, trust me, none of mine are going to be even as complicated as this. So if there's any consolation. Okay, let's go to the next one. Okay, let's look at that top section where it says cable drum. So how many weld symbols do you see there? No. There's 2 on that top section.
All the way around.
All around. 2 of them
Right.
with fillets. That's it. Yeah, 1/4 inch fillets.
You want to count both sides?
Was that?
If you add both sides, because it's on both sides.
It doesn't say both sides. It says on the outside of that.
I'm saying like, you got one on the left and you got one on the right.
Yeah, so you count those as separate. So there's 2. Okay, yeah. Except for what's
32 pairs.
yeah, and I get that. Which one are you doing? Yeah. On what side? Measuring tape? Measure that. So that's 1/4 inch. Did you see what I'm saying?
I'm counting both sides.
Why?
Because I see it on both sides.
No. Yeah, right. So this is 1 weld right here. And this is 1 weld right here. So that's. It doesn't tell you. No. Oh, no. You read it all together. You read it all together. So it's 1. So if you look at the bottom view, how many do we have? The whole bottom view. Let's just look at the whole bottom view. Let's just see if we come up with the right number. 2. We need a highlighter.
I got 21.
21 of them.
3, 4, 5, 6.
Actually, I think there might be 20 pieces. This one, the second view on the left side on the very bottom. The concrete, sort of flush. That'd be it. Just look at it. Pretty good for it.
This will actually help for the video anyway.
Same thing. Same.
Okay, we'll go in sections here. All right, so how many do we see here?
2.
Okay. Okay, let's go to the center section here.
I got 12.
Okay, so
Wouldn't that be
2,
Wouldn't that be 4?
4, 6, 8, 10,
One in the middle.
the one in 12. Yep. So we've got this next one. Okay, so we got 2, 4, 6, 7, 9. So we're 9. Is everybody seeing them now? All right. No, we're not going to do that. Okay, we've got a hot water heater. Okay, on detail B, that's the top left corner. 3. I see 3. Does everybody see 3?
I see 2
What's that?
I see 2 wheels of purple.
So, 1, 2.
Bottom left.
Oh, there's another one.
3.
You got this bottom? Oh, top.
Yeah, both sides of the line.
Oh, okay.
Where?
The arrow split.
Square.
Yeah, square.
Where's the split?
Oh, yeah.
Bottom right.
On the bottom right.
Right in the corner.
Oh, yeah, yep. So we got 4. Okay, so what do we got here?
I got one.
Who is that boy from?
Is that? Yeah, it's probably, basically these are lugs. Now there is a note on this one, we haven't really got to that. So yeah, so this one here is the only one that we see straight off. I do want to kind of point out that we were just looking at this one. Did we see this? Do we see what spec A is? So just a double check yourself, you know, when you're doing these. So let's look at this one here.
6.
I see 7 right off the bat.
6, 7, 7.
So we got 1, 2, 3, 4, 5, 6, 7.
Oh, that is
That's all one, the bottom left.
Yeah, this one here is 2 of them. Yeah, it's a fill roll and a square groove. So we're looking at it. There's a fillet somewhere in here plus something else hitting it. So it's buttoned up, so it's going to be 2 rolls in there. Let's see if there's anything else on these views here.
So as far as the top left one, when it says, all logs to be welded, is that showing anything within the hay that's going to be
Nah.
welded too?
I don't see anything right now, but I think it also kind of come down to, you know, when you see the piece being put together, there might be a couple more logs. I don't know, it's kind of hard to tell from just this.
The 1-inch standard flange, that's just part of that.
Yeah, it's standard flange. That's going to be where, because we know this is a hot water heater, it's a standard 4-hole flange, 1-inch 4-hole flange. Just has to be aligned right. So there is an alignment for that. Other than that, it's really not. It's generally. I'll leave it off here.
Spec A.
Well, there's studs that are put into these, and they want you to weld the studs up.